You've probably heard all about India's software boom, right? Well, forget that for a second, because today we're talking about something bigger, a silent revolution that's happening right now. It's this high stakes, incredibly complex journey to build the very hardware that powers, well, everything. So, that brings us to the big question, right? Why on earth is India betting over $20 billion on computer chips? I mean, this isn't just some casual investment. It's one of the biggest industrial bets in modern history. And to really get why, you need to see one number. Just one. 100%. Let that sink in. That's how many semiconductors India currently imports for its entire market. A market that's going to be worth over $100 billion by 2030. Every single chip made somewhere else. And that simple fact led to a pretty terrifying realization in New Delhi. Okay, so remember when the global chip shortage hit and it was suddenly impossible to buy a new car? Well, for India, that wasn't just an inconvenience. It was a massive wake-up call, a glimpse into this profound national vulnerability. It showed just how dangerously dependent they were on other countries for the absolute building blocks of the 21st century. And this really gets to the heart of the matter. Geopolitical dependency. You see, most of the world's most advanced chips, they're made in one of the most volatile places on the entire planet. For a country like India, that kind of risk, it just became totally unacceptable. And look, the stakes here could not be higher. We're not just talking about your smartphone. This is about the absolute critical infrastructure of a nation. Think about it. Hospitals and their MRI machines, the entire 5G network we're all going to rely on, advanced defense systems, the data centers that literally run the digital economy, all of it completely dependent on foreign ships.
So when you boil it all down, this whole semiconductor mission, it isn't really an economic plan. I mean, sure, it'll create jobs and boost the economy. That's great. But at its core, this is a national security doctrine. It's all about achieving what they call technological sovereignty.
And this is how they kicked it off. The government basically put a $10 billion blank check on the table. They called it the India Semiconductor Mission. The message to the rest of the world was loud and clear: build it here, build it now, we'll do whatever it takes. So who answered that call? Okay, this is where the story gets really, really interesting. That $10 billion bet, it was called, and then it was raised. Big time. It attracted over $20 billion in private investment in less than 2 years. We're talking about building an entire ecosystem from absolute scratch. The first domino to fall was probably the most important one. The U.S. company Micron Technology announced they were building a $2.75 billion plant in Gujarat. Now, this wasn't just about the money. This was a global stamp of approval. It was a signal to the entire world that India's mission was for real. Now, it's really important to get what Micron is actually building here. It's something called an ATMP plant. Basically, that means they take the finished silicon wafers, the really complex part that's made somewhere else, and they do the final assembly, testing, and packaging. Think of it as the crucial first step to building a whole domestic industry. But the real giant in this story is India's own Tata Group. I mean, they've placed two massive bets. First, an $11 billion fabrication plant, or fab, in Gujarat. This is the big one, the main prize, the facility that actually makes the chips from scratch. And then a second $3.2 billion ATMP plant way over in Assam. So they're building out a balanced ecosystem all across the country. Okay, but let's be real. If this was easy, India would have done it decades ago. The truth is, the roadblocks are absolutely colossal. So let's take a bit of a reality check and look at just how hard this journey is actually going to be. First, let's just talk about the cost to really wrap our heads around this. A single cutting-edge chip fab can cost up to $20 billion. That is way more than a brand new aircraft carrier. So that $10 billion the government put up, yeah, that's just a down payment. Okay, next up is the infrastructure. And we're talking about almost godlike requirements here. First, a fab needs power that is 100% stable. A single 1-second flicker can literally destroy millions of dollars worth of product. Then it needs millions of gallons of water every single day that is 1,000 times purer than the water you drink. And on top of all that, it needs a constant supply chain of over 500 specialty chemicals and gases, a supply chain that, by the way, has to be built from zero. And finally, you've got what's called the talent paradox. And this is a fascinating one. India has 20% of the world's chip design engineers. The country is an absolute superstar when it comes to designing them. But, and this is a big but, there are almost no experienced engineers who know how to actually run one of these hyper-complex manufacturing plants. An entire workforce pretty much needs to be trained from the ground up.
So, you hear all that and you think, how on earth do you solve these massive problems? Well, the answer is you don't try to do it all at once. India has a really clever, patient strategy. This is not a sprint, it's a very carefully planned 3-phase marathon.
Let's break it down. Phase 1, which is happening right now, is all about mastering the back end with those ATMP plants, like the one Micron's building. This builds up the skills, the logistics, the whole foundation. Then comes Phase 2, which is mastering the workhorse chips, the more mature but still vital ones. And then Phase 3. That's the moonshot. That's where they take all the money and talent from the first 2 phases and pour it into R&D for the cutting-edge chips of the future.
Now, you might be wondering, why focus on these older 28-nanometer workhorse chips first? Well, it's because they are the absolute backbone of the global industrial economy. They are in your car, your washing machine, in 5G towers, and in defense systems. It's a huge, stable market that India can tap into while it learns the incredibly difficult art of chip fabrication. And here's a key point. India isn't doing this in a vacuum. This whole plan aligns perfectly with the global China Plus One strategy. You've got allies like the US and Japan who are actively encouraging this because they want to diversify the global supply chain. So really, this isn't just India's bet. It's kind of become a shared strategic goal for a lot of countries.
So let's bring this all home. We started by asking if this whole silicon dream was just a fantasy or if it could become a reality. Well, the answer seems pretty clear. The revolution is already here. The concrete is literally being poured as we speak.
We're way beyond the what-if stage now. The deals are signed, the global partners are on board, construction is underway. It's really not a question of if anymore, it's a question of when. And we actually have a timeline for this. The very first chips packaged in India, from that Micron plant, they're expected by early 2026. And the first fully fabricated, made-in-India chip from the Tata Fab, that's slated for 2027. This is really happening. Look, the challenges are still huge, and failure is absolutely still a possibility. Let's not sugarcoat that. But what's clear is that a patient, multi-decade play is underway to give India a defining seat at the table of 21st century power. And that leaves us with one final thought to chew on. Is the world right now watching the rise of its next indispensable tech partner?